Good morning, student. I hope you are good and enjoying my online lessons. Students, today what the topic I'm going to discuss with you, that is about the improper. Topic is integrals. And before I start the improper integrals, I would like to discuss about the definition of improper integrals. It is kind of definite integral that is with limit, as we know. Definite integrals must give some kind of limits and are mostly helpful to find the area and volume. Yes, we can say here, I think it's better to write with this. Its definition is that if some part of a definite integral becomes infinite. Infinite means you can't define it. Infinity, the symbol of infinity. Then these integrals are known as improper integrals. Here we will discuss about two types of improper integrals. So the type number 1, what it states. As I told you, improper integral is the branch of definite integrals. So in the type 1, the rule 1, you can say these are definite integrals with at least one limit must be infinite. The infinite means infinity. For example, what is the meaning of this? At least one mean we have a definite integral in which we have limits, two limits, lower limit and upper limits. So either both of the limits should be infinite or at least one should be infinite. For example, we can say if a function have the integral limits 1 to infinity 1 over x squared d of x, you can say this is one type of type number 1. Or we have minus 2 to infinity 1 over x3 d of x, or we have integral minus infinity to minus 2 1 over x3 d of x, or we have minus infinity plus infinity. Even both can be 1 over x2 d of x. So these are the kind of improper integral in which at least one limit should be infinite. It means it can be with both limit. You can say both limits can be infinite here like this, or at least one limit should be infinite. If you talk about the other types, and before, okay, first we talk about the types. Yes, we can say this type number 2, type 2. As we are talking about the integrals, so improper integrals, so we can say these are the integrals where the function to be integrated, यानी जिसको इंटीग्रेट करना है, to be integrated approaches an infinite value at either or both end points in the interval. For example, and here you can see first where the function to be integrated approaches an infinite value, yani its answer must be infinity, as either both endpoint is in the interval. Like it's not necessary for this the limit, any at least one limit should be with infinity, but at the last the answer can be infinity when it approaches to a limit of intervals. For example, we can say if you have function -1 to 1 1 over x square d of x, when you integrate this will give you undefined. It means this function is not defined, right? When x is equal to 0, the reason is, you guys need to keep in mind, here I'm going to show a few things, few rules of whenever we have 1 over any number, let we can say it's n over infinity, that is always 0, where n is an integer. So it will, or whenever you divide any integer with infinity, the result is 0, and this is rule 1. And number 2, whenever you divide infinite result with any integer, then it will be infinite. Or if we divide any number with 0, then the result will also be infinite. Fourth, when you plus and minus any integer with infinity, again it will be undefined. If you multiply any integer with infinity, then again it will be undefined. If you take the power of any undefined number infinity, then again it will be infinity. But make sure it works where n is bigger than 0. N must be positive integer. If it is negative, If n is less than 0, then infinity power n will be 0. You know the rule, 1 this infinity is minus 1, this goes to be 1 over infinity as 0, right? So these are the two main out of these rules. Keep this in mind when result is 0 and when it becomes infinity, and this as well. So these things you guys need to keep in mind. This will help us to find results for the upcoming questions. Okay. Let's start few examples to help us how these kind of techniques for improper integrals should be helpful to solve a definite integral. I'm going to write a question for you. Question: show that the integrals 1 to infinity 1 over x square d of x has a finite value. First thing we need to show this, and number 2, find the the finite values. Okay, this is a question. So how to solve this? Before I start, I want to comprehend the question. You can see this is show that the integral this one has a finite value. Finite value mean it must exist with any integers, right? And what is that value? We need to find that in part 2. Let's start this question. We need to integrate this 1 over x square d of x, bring the denominator function in numerator so its power becomes negative. Now you can see the function is x whose power is minus 2, and x has its differential dx along with it. So as a rule here, I'm going to write x power n d of x. We need 2 plus 1 divided by the new power plus c, but here we will not write c because it's a definite integral, so c can be cancelled as we have discussed in the previous lessons. Sorry. So here we integrate it simply, it becomes x power minus 1 once you add 1 in the power. Okay, let me write 2 plus 1 divided by minus 2 plus 1, and the limit goes here 1 to infinity. So after simplification it becomes like this, 1 to infinity. So we know the rule, x raised to power minus n can be 1 over x raised to power n, and is integer. By using this I can rewrite this negative exponent of the function like this minus will be minus 1 over x 1 to infinity, right? X power 1 mean x. Now apply the rule. How to apply the limits? This is upper limit, this is upper limit, and this was the lower limit. So we always use, this is lower limit, we apply the upper limit here 1 over infinity in place of x. Upper limit minus is by default minus, and again it is minus 1. Lower limit of x, that is 1. So you see minus 1 over infinity minus 1 plus 1. As we know 1 over infinity was 0. Here you can see I wrote n divided by any infinity, any integer divided by infinity becomes 0. So by using this rule, I told you the important rule, So this whole becomes 0 plus 1. So this is the finite value, and we have to prove this is a finite value. Yes, and along with it we need to find what is the finite value. Finite value is proved. Here you can say it's proved, number 1, and number 2, finite value is equal to 1.